As we finish up lesson 4.7, let's look over here and see what our learning goals are today. I can use point-slope form to write a linear equation in slope-intercept form. So in other words, we'll put it in point-slope form first, and then we'll get it solved for y so that it's in slope-intercept form. And in the process of that, we'll also use one of the other objectives that was in the book where they used the x and the y intercept to help you do that. And then I can write an equation to represent a real-world problem and use it, okay? So we need to be reminded what is point-slope form. What's the model for point-slope form?
Y.
So point-slope form goes like this. Y minus y sub 1 equals
M
parentheses
x minus x1.
x sub 1. Okay, there you go. Good job. And we have to put it in slope-intercept form, which that one should be a piece of cake for us to remember. Now, what is slope-intercept form? Yeah, y equals mx plus b. So they're asking us to put it in point-slope form first, and then rename it in slope-intercept form. So, number 1, we have the slope of negative 1/3. Which variable does that represent in our model?
Slope.
M. Okay. And they tell us that ordered pair negative 3/8 is on the line. Well, let's see if we can save ourselves any work. Is that the y-intercept?
No.
No. How do we know it's not the y-intercept?
Because x isn't 0.
Because x isn't 0. So we're going to make negative 3 our x sub 1 then, and our 8 our y sub 1. And now we can substitute into our point slope form and go to work. So y subtract what? 8 equals negative 1/3 times x take away negative 3. Okay. Now we can change that to add the opposite, right? So this will become add, and the opposite of negative 3 is positive 3. Now do not even uncover those calculators. We don't need them today. Okay? What do we have to do next?
Multiplying.
Multiply. We need to get rid of those parentheses over here. What property is that called when we do this? What property is that? Multiplication over addition. Distributive property. So we're going to do distributive property on that side. This side we'll just leave alone. So we have negative 1/3 x plus a negative times up. We're taking negative 1/3 times 3. What's a negative times a positive? A negative. And 1/3 of 3. 1/3 of 3 is, we have 3, and I want to divide it into 3 parts. I want one of those. 1. Oh my goodness. See how calculator dependent you are? It's pathetic. It's a sad, sad, sad state of affairs.
Future.
Okay. Now what do we do? Is it in slope-intercept form yet?
No.
Add 8. Add 8. We're going to add 8 to both sides to get that y alone. And then we will have our y alone, and maybe it'll be in slope-intercept form. Y equals negative 1/3 x plus 7. Negative 1 plus 8 is 7. That looks like slope-intercept form to me. Y equals mx plus b.
Aren't you adding 3 up there though?
Aren't you adding 3? So we had to multiply that 3 by the negative 1/3 because it was inside these parentheses here. Remember we did this?
Oh, okay.
Okay, we did the distributive property. Okay. Any other concerns? Okay, let's look at the next one. They give us 2 ordered pairs. What do you think we have to do first?
Find the slope.
We're going to find the slope, don't we? Yeah, so we're going to have to use the slope formula, which is already in our memory too. So m equals, let's make this one x sub 1, y sub 1. Let's make this one x sub 2, y sub 2. So what are we going to have upstairs? Negative 5 take away 5. Negative 3 take away negative 1. So we have to have a good setup first of all to make sure we get a good slope. And then we can do some change to add the opposite, add the opposite, add the opposite. So what's our rise become? Negative 10. What's our run become? -2. A negative divided by a negative is a positive. 10 over 2 is 5. So we now know our slope is 5. And we're going to write an equation in point slope form, unless one of those points they gave us is the y-intercept. Is it?
No.
Unfortunately not. So we're going to go to writing our y subtract. Let's use the one that we did name as x sub 1, y sub 1. How about y subtract 5 equals, our slope is 5 we just found out. X subtract what? -1, right? It's -1. Then that can become, add the opposite. And we'll do our distributive property. Go ahead and finish this one. Let's see what we get, what you get. Do you agree with me? Does it need cleaning up? No. That would be how we would see it in an answer bank. Okay, so we did one where they gave us the slope and a point on the line that was not the y-intercept. We did one that they gave us 2 points. Neither of them were the y-intercept. Now we're going to do one where they give us both the intercepts. So what are we going to do there? Myself?
We can make them into like 2 separate points.
We can make them into 2 separate points. These are points on a graph, aren't they? So what is the ordered pair name for the x-intercept? What's this one's name? -2, 0. Okay, so, and what's this one's name? 0, 3. Okay, go ahead and find the slope of that line. Find the slope of that line. And there's 2 ordered pairs. They just happen to both be the intercepts, but still 2 points on the line. Did you get 3 halves? Okay. So we now know the slope, which, do we have to work a whole lot harder now?
No.
What do we have to do?
You can put it inside the.
Do we need to put it in point slope form?
No.
Why not?
Because they gave us the y-intercept.
They gave us the y-intercept this time. Are we ready to write an equation in slope-intercept form? Absolutely we are. Go ahead and write down what is it. What is this equation? What's the equation of this line written in slope-intercept form? What do you have, Sadie?
Y equals 3 halves x plus 3.
Does it need cleaning up? No? Okay. How many of you agree with Sadie that that's a good answer? Yeah. They gave us the y-intercept and said it was 3, right? And how many names again does an equation have in slope-intercept form? How many different names can you give the equation of a line in slope-intercept form? Or in other words, let's just say, let's go back to the second one that we did. What if we had used this point instead? Would we have gotten a different name here?
No.
Okay, why not? How many names does an equation? One line, just one line on a graph. How many slope-intercept form names does it have?
1.
Only one. Why only one?
Because it's the slope-intercept.
The slope and the, so slope-intercept
Slope and
form.
the y-intercept.
And can there be a different slope ever for one line? Can there be a different y-intercept ever for one line? No. So this would be the only name. When you find the slope-intercept form name, it has to be that name, because it only has one slope-intercept form name. How many point-slope form names does it have, though? Infinite number, because when you're writing in point-slope form, you're using one of the points and the slope, and there's an infinite number of points. So you can have several different names for those. That's okay. Let's go to the back side and do our other objective, our real world problem, which happens to be number 35 on the homework page. You don't have to do 35 in your homework, but you do have to do some word problems. So let's see. Go ahead and read that and make a decision. What do you think should be the independent variable and what should be the dependent variable in this problem? Where we have at higher altitudes, water boils at lower temperatures. It's the one we're on. So remember, the independent variable controls the situation. The dependent variable ends up because of what happens with x. So what do you think should be the independent variable, Nick?
Altitude.
The altitude in, what's it measured in?
Feet.
Feet? Or in other words, so how high up it is controls what then? What's the dependent variable? The boiling point, temperature in degrees Fahrenheit. So let's say altitude in feet, and that makes sense that however high you are up, that controls what temperature the water is going to boil at. Not the temperature that the water boils at controls how high up you are. Okay, so we'll just put temp in degrees Fahrenheit. We don't have a whole lot of room. Okay? Well, given that x then is altitude in feet and y is temperature in degrees Fahrenheit, what would our two ordered pairs be that we could set up from this problem, from the information that they gave us? What's one of the ordered pairs? Nick?
1,000 and 210.
Okay, so that's telling me that at 1,000 feet, water boils at 210 degrees Fahrenheit. Is that what it said? Okay, what's the other one then? At 3,000 feet, it boils at 206. Okay. So we have a couple of ordered pairs. Are either of those the y-intercept? No. Do we know the slope? No. Can we find the slope? Yes. Okay, let's go. No calculator. We're not going to change it to a decimal. We're going to leave it as a fraction. We're going to work with it as it is. So give me a setup here for slope.
206 minus 210.
206, take away 210 over 3,000, take away 1,000. Okay. Justin, 206 take away 210 is? Justin.
Oh. 206, take away 210, that's
Negative
-4.
4. Justin, 3,000 take away 1,000 is?
2,000.
2,000. A negative divided by a positive is a negative. I wonder what 4 divided by 2,000 is. Is it 500?
Yes.
No. You can't take a small number and divide by a big number and get a fairly big number.
Be like,
Good job.
20.
What's-
Oh,
How
sorry,
about
I did that wrong.
Would 2,000 divided by 4 be 500? Would 2,000, if the 2,000 was upstairs and the 4 was down, yeah, but that's not the way it is. So we have to simplify this as a fraction. Does 4 go into 2,000? Okay, how many times?
500 times.
So it goes into itself once and it goes into 2,500 times. We're going to leave our slope just like that. There's our slope, a -1/500. We have to, first thing they wanted us to do is write an equation in what form? What did they say? Slope intercept form. Okay, well we'll start with doing it. Trust me, this will be a lot nice, probably a lot nicer doing point slope forming. Anyway, so let's start with, and then we'll get it to slope intercept form. So y take away, which point do you want to use?
206.
This one?
No, 210.
Oh, now you want this one.
Yeah.
Okay, So y take away 210 equals negative 1/500 x take away, we're using that one, right? 1,000. Now trust me, you don't need your calculator for this. I know you think you do, but now I highly recommend that when there is subtraction involved in a distributive property problem, change it to add the opposite so that you will multiply properly. So we're going to leave that side as it is. Y take away 210. We're going to leave the slope, or no, we're not going to leave the slope. We're going to take the slope times each of these. So this is going to be negative 1/500 x plus what? A negative times a negative. First of all, okay, let's just go over here to the side. We got 1/500 getting multiplied times 1,000.
2.
Yeah, this is not hard. 1, 2. It is 2. 1/500 of 1,000 is 2. Okay, go ahead and finish this and write the equation that represents this situation given any altitude or any boiling point. So there's our equation in slope-intercept form, right? Okay, they want us to do anything else? Okay, find the boiling temperature at 6,000 feet. So basically it's saying to us, you're going to find either an x value or a y value. What is the 6,000? Is that our x or our y?
X.
That's x. So we're going to look for y. So we're going to use our equation. Y equals negative 1/500 times 6,000 plus 212. Again, we do not need our calculator. Trust me, you guys can do this. You're going to put this over 1. I can take these two zeros and cancel 2 of them off upstairs. So I really have right now a 60 divided by a 5. 12. And a negative times a positive is a
Negative.
negative. This is negative 12. Oh, and even easier yet, we have to add a negative 12 to a 212. What's the temperature at 6,000 feet?
Oh.
What is it? 200, and its label would be
Degrees Fahrenheit.
degrees Fahrenheit. Okay, now let's just take a little bit of time to decide if that seems like a reasonable answer.
Yes.
Because what was happening in this situation? As the altitude goes up, what's happening to the boiling temperature? It's going down. Yeah. And so this just, it was 1,000, then it was 3,000, now it's up to 6,000. At 1,000 it was 210, and then it went down to 206, and now it went down to 200. So does this seem reasonable? Yes, it does. So we can say, okay, probably have a good answer. So any questions about, because you have some more problems doing your homework, any questions about this one? Okay, let's go to work on homework then.